right. Thank you for coming this morning for 8 a.m. I hope you're enjoying your reinforce. Can I get a thumbs up that everyone can hear me okay? Awesome. Well, cool. This is IAM 303, Strategies for Achieving Least Privilege. My name is Josh Julak. I am a Security SA Manager with AWS.
Hello everyone, my name is Matangi Ramesh and I'm a Senior Product Manager with the Access Analyzer team.
Awesome. And just to kind of level set as well, this is Strategies for Achieving Least Privilege in AWS IAM. So we're going to be focusing on AWS Identity and Access Management, not application identity, not infrastructure identity. So I just want to level set and make sure you're in the right place for that. So let me start with three. Okay, cool. Well, let me start with three questions. Where should I start? Which policies should I use? And who can access what? If these are questions you've thought of or are wrestling with, at least in the context of AWS IAM, then I do think you're in the right place. And we've spoken about least privilege before. We've spoken on these questions or these topics before at reInvent 2021 and reInvent 2020, and even before that. And so, feel free to take scans of the QR codes throughout today's talk. We're going to have a number of QR codes, or if you're watching the recording later, those will be available to you. So this is more of a complementary to those previous talks as well. So hopefully fresh material for you. But I do think you're in the right place if these are questions you're thinking of, at least in the context of AWS IAM. And we're here to give you some simple strategies to get started. So the agenda today is we're going to look at an overview of least privilege on AWS. We're going to dive into 9 strategies for implementing least privilege in AWS IAM, and then we're going to zoom back out for some key takeaways. All right. So let's jump into kind of an overview of least privilege. So what is least privilege? Well, essentially it's to grant users and systems the narrowest set of privileges to complete required tasks. And in principle, this is great, right? This is the ideal that we want. We want just the right amount of permissions, ideally not any more than necessary. But it's not so simple. Users change or systems change, the cloud changes, AWS is adding new services or features. Individuals on your team might want to adopt those new services or features. Perhaps there's a cheaper way of doing what you've been doing before. And then the permissions would need to be updated to reflect that as well. And so choosing the narrowest set of permissions could be too restrictive. And so a lot of customers we talk to are looking for a more pragmatic approach or a more pragmatic answer. And to be more pragmatic, you'll want to recognize that you're kind of balancing two competing goals, right? There's things you don't want and things you do want. Things you don't want would include dangerous actions or maybe expensive actions, teams launching expensive resources or even terminating static resources that you don't want to disappear, and just generally being unaccountable, right? And then there's things you do want. You want your organization to innovate. You want your builders to have a little bit more freedom, to be agile, to find cheaper ways of approaching the same problem. So there's a natural tension here between these two competing goals when you're thinking about least privilege. And we're going to talk about how to try to find a better balance across them. And Maddie and I speak with a lot of customers about this topic, and they tell us that we have a lot of these components in our cloud environment. And I often get asked, where should I start, right? And you might feel inclined coming into this session that we're just going to hyper-focus on policies and kind of brute force our way to least privilege. But that's not very effective. And so we're going to take a slightly different approach there. Because more importantly, you need the context about the applications, about the users, about the workloads. You need to understand the intent and the constructs behind that. What APIs is the code referencing? And then obviously you also need to take into account the roles and the accounts that they live in. So we're going to try to break this question down into 3 kind of subcomponents: strategies, mental models, and tools. And I often get asked about mental models and like what is that? What is, or why are we using mental models? Well, it's a fairly loosely defined term, but I think of it more as conceptual models or frameworks for thinking that takes something relatively complex and tries to break it down into something simpler that you can reason about the complex topic in a better way. And this means we're naturally leaving out detail, right? If we move from something complex to something relatively simpler, we're choosing to leave out some detail just so we can reason about the complexity a little bit better. And I like this quote from George Box. He says, "All models are wrong, but some are useful." And I think that's very applicable here as well. And so, there might be an edge case that during today's talk that you're thinking of, and I'm happy to talk with you after the session as well about that. But just keep in mind that we're simplifying some of the discussion in order to reason about it better. So whenever we're highlighting a mental model, we're going to use this little pink tag to kind of point out where those exist. All right, so let's start by breaking this down into who, when, and how. Who is important because we want to talk about the personas that are using least privilege, and then we want to talk about when they are implementing least privilege in AWS IAM, and then how they're doing that. And again, we're talking in the context of just AWS IAM, so if you're joining us a little bit late, we're not looking at application identity or infrastructure identity, we're just focusing on those cloud identities. And so this is what we typically see within, or with customers in the cloud. In a lot of cases, they have essentially two sets of teams, decentralized teams on the right and centralized teams on the left. If you think of decentralized teams, you might think of developers or groups of developers, operators, contractors working in your cloud environment. On the left-hand side, you might recognize names like the cloud platform team or the infrastructure team or the security team, the network team, the identity and access team, right? And each organization is different though. I talk with enterprises, government agencies, startups, and there's variations of this. So if this doesn't reflect your organization, that's completely acceptable, and that's okay. Not everything here will apply to you today, but it could apply to your organization as it continues to grow. So just keep that in mind. But this is typically what we see, and it's split into two kind of categories of decentralized and centralized. And so knowing that, we want to talk about when they're working with least privilege, right? And often we break that down into three scenarios. There's kind of the baseline set of roles and permissions that are necessary to start using the cloud. And those are created by the centralized team. So that could be creating the initial default roles and policies that you deploy using your account factory or control tower in order to allow your teams to federate into. Or maybe you have some automation that's doing the monitoring in the accounts, but those need roles and policies as well. So the first scenario would be deploying that kind of baseline set of default roles and policies into the individual AWS accounts. And centralized teams usually perform those actions. After that, the more decentralized teams, or what I wrote here, developers, are going to go build something in that cloud environment using those roles that we just talked about, right? So they need to create new roles and policies for the applications, because those applications need to interact with data, S3, SQS queues, that sort of thing. So creating those roles and policies is that next scenario, and that typically happens by a more decentralized team. And then lastly, the third scenario would be verifying and refining existing permissions, and that's the responsibility, or at least in my eyes, the responsibility of both sets of those teams, right? It's everyone's responsibility. And so how do they pursue least privilege? Well, it's a life cycle, right? They're setting permissions, they're verifying the permissions, and then they're refining those permissions over time. And this continuous improvement or feedback loops adds up to the journey to least privilege. And we often call least privilege a journey. It's not something you achieve day one, because again, things are changing, users, systems, the services change or add additional features, right? But the journey here is made up of these feedback loops of continuous improvement. All right, So now that we've kind of level set a little bit of overview knowledge, let's dive into strategies for implementing least privilege in AWS IAM. And we actually have 9 strategies to talk about, but to kind of simplify it a little bit better and to structure it more logically, we divided them into 3 categories of plan, policy, and process. Plan is where you consider your goals and the outcomes that you want to achieve and then design your cloud environment to simplify those outcomes. Policy is where you're going to implement some of those goals in either the IAM policy language or as code, infrastructure as code perhaps. And the process is where you're going to take a more iterative approach to continuous improvement. So let's look at the first one. Begin with coarse-grained controls. With coarse-grained controls, we want to start higher up or broader within our cloud environment. And most systems have relationships, and these relationships can be modeled or visualized. And so it's helpful to think in terms of a hierarchy, right? And perhaps this is not new to you. There's a organization's management account, and you can group your accounts within that, which we'll dive into. But I think it's helpful to construct a hierarchy mental model in your mind. This is an iSchool diagram that can help visualize this a little bit better, and we're going to kind of use variations of this throughout the talk. And you might be tempted to come into this session thinking we're just going to hyper-focus down here on the principles and the policies that are assigned to the principles or to the resources, but we're not. We're going to start higher up than that, and we're going to use some of these coarse-grained broad controls such as multi-account strategy, service control policies, block public access, before tailoring the permissions lower, right? We want coarse-grained at the top before we do fine-grained controls at the bottom. And one broad-based control that you'll want to keep in mind, but not necessarily pursue directly right now, is a concept of a data perimeter. If you're not familiar, a data perimeter is just a set of preventative guardrails that ensure that only your trusted identities are accessing trusted resources from your expected networks. Now, to be clear, data perimeters is not a service or a feature. It's kind of the culmination of a set of these features or capabilities on the left. So as you layer in these controls, they can culminate or add up to data perimeters protecting your data, right? And so you'll establish these security controls on the left and build upon each other over time. So it's not something to set out to cover today, but rather as you approach some of the other items that we talk about, you'll ultimately add up to this. And hopefully you can scan the QR code here if you're not familiar, but this will be available in the recording as well. So we have additional information and resources on what data perimeters are and how to achieve that. Okay, so let's move on to our second one, use accounts as strong boundaries around resources. And you've probably heard someone mention it today or yesterday or later in the week, but about multi-account strategies, which is a best practice in AWS. While you can start with a single account, just as your workloads are growing or as your organization grows, you should split those up into various accounts that you can group together. This is a security best practice, but it also simplifies other things like billing, right? And customers can then group these accounts into different assortments using AWS organizations. You can group them into what's known as an organizational unit or OU. Some customers will choose to do this by environment, so dev, pre-production, test, production, or business units or cost center. The choice is yours on how you want to construct this, but one thing to keep in mind is you can leverage this for grouping security controls. So as you layer in preventative or detective controls, you can do that on groups of accounts based on the grouping you choose. So when you're thinking of how to group these accounts, also think as, where do you want to apply your security controls that could affect permissions and therefore assist you in that journey to least privilege. And so the point is, though, that AWS accounts give you strong boundaries between resources and the principals and networks in those accounts. And so by default, these principals and resources at the bottom cannot cross these boundaries. And we're just representing that here with the kind of pink dotted line. But we have our organization with 2 accounts, and then we have someone else's account here in pink, right? And in order for any of these accounts to communicate with each other, we need to explicitly enable access, right? We need to add the permission for them to communicate. So things like cross-account resource sharing or cross-VPC or cross-account role assumptions, we would need to explicitly enable that access. And so because that access is explicitly enabled, someone has to create the permission for it, and then we could review those permissions in order to see if something is enabled to cross those boundaries, right? And we can do that using IAM Access Analyzer. And we're going to talk about IAM Access Analyzer a lot today. There's essentially 3 major components to it. So the first one we want to talk about is cross-account findings, right? Now, Access Analyzer helps you identify resources in your organization or accounts, such as Amazon S3 buckets, IAM roles, SQS queues, and so on, that could be shared with an external entity, like we just kind of visualized there. And this helps you identify if there's unintended access that your resources and data are being shared with another entity or another account, and could be a security risk to your organization. And so it's pretty simple to get started. There's essentially 4 steps. You just create the analyzer, and it begins analyzing those permissions that we just talked about. And they will start producing findings, right? And you'll want to review those findings and look for 2 things: intended access and unintended access. So if it's intended and you wanted to share your data with another account, you could just archive that. But you'll want to hyper-focus on the unintended access, right? You'll want to look for whether or not that account was in your organization, perhaps who enabled it. But you'll want to go remove that unintended access and remove that security risk. Now, I want to also highlight what I think is an underrated feature here. IAM Access Analyzer is integrated at the organization level. So you can go to your organization management account or the delegated member account and configure an Access Analyzer for your entire organization set as the zone of trust, right? So if you're sharing beyond your organization rather than just individual accounts. So let's look at more of a visual example here. Let's say we have 3 accounts, A, B, and C, and we want to consider whether a role from account B can access a resource or a SQS queue in account A, and a role from account C can access a bucket in account A. Well, before IAM Access Analyzer, I would have to go look at these policies and evaluate the permissions in them and understand what APIs are available and whether or not the conditions are allowing something or not. But with IAM Access Analyzer, once you turn it on, it starts evaluating those policies. And it uses automated reasoning and SMT solvers, which you can just think of as fancy math, to prove whether or not those policies are allowing or not allowing that access. So whether or not something is true or false, right? And this helps us validate our assumptions and find intended or unintended access in a more automated way across all of our strong boundaries. Right? All right, so let's move on to our 3rd strategy: prioritize short-term credentials. So when it comes to access control, I tend to think that shorter is better. Short-term credentials are requested dynamically using strong identities, and rather than keeping a long-term access key that's stored in plain text on your laptop and could find its way in interesting places. And there's several hopefully obvious benefits with that is if they're being requested dynamically, they're also temporary and they automatically expire. So you don't have to revoke them or rotate them. You don't have to embed them within your application. Using the AWS SDKs, they can just request through a credential chaining to get a short-term credential from a credential provider, and which in the case of AWS is essentially IAM roles using STS, right? Security Token Service. And so in the context of AWS IAM, which is the context for this talk, when we're talking about short-term credentials, we're effectively using IAM roles. And we can kind of split that into 2 categories with subcategories. But I look at it as short-term credentials for builders and short-term credentials for applications. So builders typically interact with the cloud in one of two ways, either through the console on a web page, or more programmatically through the CLI, for example. And for the console access, they can use direct federation from your identity provider to individual AWS accounts, or something more centralized through IAM Identity Center, which is the successor for AWS SSO. And then programmatic access, you can get short-term credentials for CLI access into an AWS account. And this is actually fairly simple to do with IAM Identity Center, or you might think of as AWS SSO. But those are typically the two ways to get short-term credentials for interacting with AWS if you're a human, a builder in your environment. Now, those builders are creating applications, and those applications need their own permissions. And so typically for short-term credentials for applications, we're looking at IAM roles for EC2 or IAM roles for Lambda or tasks. And you can actually even use IAM roles on premise now. Recently, we just launched IAM roles anywhere, which gives you the ability to have an IAM role for like an on-premise machine that perhaps needs to upload some logs or data to an S3 bucket. And then lastly, cross-account access, which we were kind of talking about there with crossing those strong boundaries. There are use cases for that. If you have a build tool, for example, on one account that needs to push or deploy resources or infrastructure to another account, or a partner tool that needs cross-account access for monitoring, that sort of thing. But obviously, organizations still have long-term secrets, like passwords that don't use IAM roles or need to be stored somewhere because an application needs to access the database. And so you can protect these with AWS Secrets Manager, which will encrypt the secret using a KMS key, and you can configure automatic rotation of that secret. And this will help reduce the risk of those long-term secrets, and kind of mentally, I think it was more turning a long-term secret into a shorter-term secret because of that automatic rotation. All right, kind of closing out the plan category there and moving into policy. Our fourth strategy is to enforce broad security invariants. And so what do we mean by invariants? Well, invariants are essentially conditions that should always be true, right? And we can enable that by using service control policies at either the organization level for all of our accounts, or perhaps a group of accounts using an organizational unit, or just individual accounts, right? So we can apply a service control policy at any of these layers, which is again that coarse-grained, broad set of controls. So what are some examples? Well, a best practice at AWS is not to use the root user. And so we would encourage you to block access for that root user. Or perhaps there's regions that you, as an organization, are not using. And so you can choose to disable access to specific regions that you don't want resources deployed into. And you're also probably configuring logging and monitoring. And so you could use service control policies to disable CloudTrail, CloudWatch, GuardDuty, that sort of thing. Once you enable them, you don't want your users to disable them, right? So notice these words: block, disable, prevent. If you're thinking of these words in the context of all users or all principals except for the administrators, that's where service control policies can come into play, and that's when you'll want to think about broad security invariants. So this sounds great, and the customers will ask me for, what else should we prevent? Help me kind of analyze this more broadly. And I use a mental model, a relatively simple mental model here, just an XY graph. And along the x-axis at the bottom would be the potential risk of somebody using that service or API in a particular account or environment. And then the y-axis would be the frequency of the use, right? How often does that action occur? And so at the top left would be those actions that are probably occurring more, the read-only actions, right? Describe and list, those are relatively safe. While at the bottom right is where I would want to focus my time, right? If I'm enabling CloudTrail for logging, I would want to make sure somebody doesn't call the stop logging API or to delete the CloudTrail. And so those actions would be risky in my environment. but they also have a fairly low use. People shouldn't be just calling stop logging every day, right? Or more situationally, direct connect. You're configuring your network and you're probably not changing it very often, or the only users that are changing it are the network administrators, right? And so over time, you can kind of think of this as, what do I want to block or prevent? What can I use as preventative guardrails for things that should never happen? Versus maybe there's other guardrails for things that are more situational, right? And you could move from preventative to detective. You'll need to take into account maybe what personas are using these or what environment they're in. And so, but you can do this essentially service by service before thinking of it more fine-grained feature by feature, right? So here's an example of a service control policy. You can put a block public access configuration in S3 for an account in order to ensure that even if a bucket has a permission to make it public, that at the account level you're disabling that overrides that permission, right? So buckets by default aren't public. Somebody could choose to add a permission to make it public, but you as an administrator could override that and restrict that with that feature, that block public access, right? So you want to make sure that people are not manipulating that access unless they're the administrator, right? And so this SCP essentially says we're going to deny that API unless your principal is the role named admin, right? So essentially we can add this broad security invariant for all of our accounts. Now you'll notice that we're just denying this permission unless you're the admin. There's nothing here that grants a permission. And so we need that permission on the admin somewhere else. We can't do that at the SCP level. SCPs are just guardrails. They don't grant permissions. And we're going to look at kind of choosing the right tool for the job here in a second. And rather than kind of coming up with these yourselves, I like to point customers to two documentation pages. On the left is some example documented service control policies. But I do want to point you more to the right-hand side of Control Tower guardrail references. These are ones that Control Tower offers if you choose to use it, but they're publicly documented. So even if you're not using AWS Control Tower, you can still take advantage of the SCPs that are defined there and tailor them based on your environment, right? Okay, and with that, I'm going to hand it over to my colleague.
Thank you, Josh. Good morning, everyone. So as per what Josh mentioned, you've set up your organization, you've mapped out all your accounts, and you've identified what is the hierarchy that you want. The next step is to control who can access or like what access is allowed in those accounts. And for that, the important strategy here is to identify the right tool for the job. You've probably heard the saying that goes, if Hammer is the only tool that you have, then you'd be tempted to treat every problem as a nail, and that wouldn't work. In the same way, IAM offers a lot of tools, and each of those is valuable in its own way. If you had to bucket those, I'd bucket those into two different things: the guardrails and the grants. The guardrails are those set of tools that help you restrict or deny access to your accounts. So at a high level, they help you figure out what's the boundary for the right set of permissions that you want to retain. So service control policies, as Josh mentioned, is a great example that helps you restrict what the principals in your account and your organizations cannot do. For example, if you have CloudTrail, you'd want to say that no one in this account should be able to disable my CloudTrail. Permission boundaries is another great example that allows you to say what's the maximum set of permissions that are allowed to a particular role. We'll get to that in more detail a little later. So these are the grants, these are the guardrails that sort of help you restrict access, but they don't inherently grant the required permissions for what is allowed in your account. To be able to do that, you use either an identity-based policy or, as it says here, a principal policy or resource-based policies. The identity or the principal policy is something that you attach to a role, or a user, and the resource-based policies are some things that you add to your resources like an S3 bucket. If you could boil down the whole of IAM to one single sentence, it comes down to who can access what. So when you're thinking about grants, you can address that from the who angle by focusing on the identity-based policy. So imagine you have Bob, who's a developer in your team, and you know that Bob traditionally works with EC2 and S3. So then it's easy for you to create an identity-based policy that grants Bob's role just those permissions. On the other hand, if you know that you have a set of resources like S3 buckets where you want to save all your financial reports, then you know what actions can be taken on that bucket. So that's when you target the grants from the resource or the what angle and identify what your resources are and what permissions or what actions can be taken on those resources. The one nuanced difference here is in the case of the identity policies, the principle is implicit. You know that you're creating that policy to provide Bob's role that required access. Versus in a resource-based policy, you need to call out the principle explicitly. You need to be able to say, like, can Bob's role access this bucket? If yes, then add the roles on in that policy. So these were the grants and the guardrails at a very high level. And there's a lot of documentation that takes you in more depth. But to summarize this, if you have multiple guardrails in your accounts, the net effective permissions is going to be a combination or a union of all of them. If you have multiple grants, like an identity-based policy and a resource-based policy, again, the permissions or the net effective permissions are going to be a combination of the two. But if you have, say, an SAP policy and an identity-based policy, the net effective permissions is the intersection or whatever is common between the two. So if, for example, you have an SAP that says no one can access CloudTrail, then no matter what permissions you provide Bob's role, the role cannot access CloudTrail. And I would like to call out a blog. Like, this is a great blog that talks about all the different tools that are available in IAM and how can you put all of those together and make them work well together. So you've identified the right tool, you start writing policies, and you start working with the flow. And then you see, how many of you have seen this happen? We hear this often from customers. So you have a lot of developers in your account, in your team, and they are the ones who are focusing or building the application. They know what are the permissions that's required for that application, but they're either not comfortable authoring those policies or they just want to focus elsewhere. So that's where the administrator comes in. That's where they step in. They help the teams to create those policies. And this works well for a while. But as the business grows, as the team grows, this soon becomes a bottleneck. And the mental model to remember here is that always be on the lookout for what the bottlenecks are for your team and your organization, and try to identify the root cause and solve for it. Sounds obvious, but then like as you get into the motion, this doesn't be any obvious anymore. And what happens is like something that worked for you, say 2 years ago, doesn't work for you anymore because your teams are changing, your organization is growing. And the root cause here still is that the developers are not as comfortable authoring those policies. So the question is, how do you create that safe space or provide opportunities in such a way that developers can confidently and safely create those policies for their applications? We can start with something basic. Invest in training. AWS offers a lot of workshops that help you get started with authoring policies. And you can either leverage that or have something in-house more custom for your organization to give them that hands-on experience to get them started. And as time progresses, you can help them along the way by setting up processes that work for you. So for example, peer reviews that we'll get into a little later. And along the way, you can also leverage a lot of AWS native tools, such as permission boundaries, IAM access analyzer, policy generation, that help you empower your developers to do this on their own. So in the next few slides, I'll talk about what are those native tools and how you can leverage them. I mentioned permission boundaries earlier, and what it helps you do is it helps you set what's the maximum available permissions to a particular role. And a common way in which we've heard a lot of customers use this is by adding this to your developer or builder roles to sort of define what's the boundary for what they can do. This way they create a space for with the maximum set of permissions that's available to the developers and confidently let them play around in that account. I want to call out another key way in which permission boundaries can be leveraged is to delegate the responsibility of policy creation to your developers. What we are saying here is that you can add conditions for the builder role or Bob's role to say that whenever this person or this role creates a policy or creates a role, they need to add a permission boundary. So this way, whenever they are working on their application and they're creating roles to grant those applications the required permissions, they are required to add those permission boundaries, which then bounds the maximum permissions available to those applications. So even if the policy that they end up writing, which is custom for their use cases, is not too fine-grained, the permission boundary helps you ensure that it is not outside what you intended for your account. The next tool that I want to talk about is IAM Access Analyzer policy generation. So at a very high level, what this feature or what this tool helps you do is it looks at your CloudTrail, it reviews your CloudTrail to identify what are all the services and all the actions that you've used recently to then create a fine-grained policy that meets your needs. So the classic use case, again, the application scenario. If the developer has tested the application for a while in their account, say for the last 7 days, they want to now write a policy that they want to submit for review before they can move the application to production. A great way to do this is run policy generation in that account for the last 7 days, and then figure out, IAM Access Analyzer will give you back that policy, which can then be a starting point. The developer can make some changes in that policy to fit it or change it to their needs, and then just skip a few steps in this iteration of policies. I want to quickly show you how you can use this in the console. The feature is available through APIs also. In the console, when you look at a roles page, there's a section that goes generate policies, and over there you can create a policy in 3 simple steps. First is to select a time window. A lot of customers talk about share that they select the last 7 days. That traditionally captures all the required or regular activity that happens. Select the trail from which you want the data to be reviewed. Provide some permissions for Access Analyzer to be able to access that CloudTrail, and just click generate. And once you do this, the policy is generated. Take a look, identify if something is missing, put in that information, and create the policy. So you've identified all the right policies. You've empowered your developers to start authoring policies. How do you account for scale? By investing in processes. And that's the area where we want to focus with our next 3 strategies, starting with maintaining well-written policies. Not every policy needs to be artisanal. And we say that it's actually wise to reuse your policies across your accounts. And in this rare case, I'd actually say that plagiarizing a good policy is actually a great strategy. How do you do this? When you're getting started in a new account, we actually recommend using AWS managed policies. These tend to be broad policies. But as time progresses, what you need to do is identify those use cases that keep happening or that's common in your accounts and create templates for those. A classic example is you have your accounts for your development teams to work in, and when they create applications, the applications tend to read and write data, say, from S3. So create templates for such policies to be able to read and write, that grants permissions to read and write from S3, And the key here, or the important step here, is to make these templates findable. We've heard some customers who do this through internal wikis where they want to keep it well documented so that their teams can just search and find what template works for their use case. Some customers we've heard version it, use infrastructure as code to save it in their repositories and then just work from there. So figure out what process works for your team and go from there is what we'll say. The one thing that I'd like to call out here is developer needs tend to be very different from application needs. For example, when a developer is working with resources in your accounts, it could be to create a resource, delete a resource, for example, creating and deleting S3 buckets. Whereas when an application is working in your account, it's to read data. So it will be to read and write objects to that bucket that was created. So when you're talking about, when you're creating these templates, identify the nuances of like who are you creating this template for, and find out what the difference is, and create a template accordingly. And another thing I want to call out is the reuse of these templates or creation of policies that work across your accounts. For certain use cases, it's easier to create those policies across all accounts. For example, if you have central security teams who want to go into all of the accounts to routinely review what's happening there, the kind of practices they do in each of these accounts is going to be pretty constant. So you might want to give them access to CloudTrail, you might want to give them access to GuardDuty and other such services, but you can create this policy and have the same policy across all your accounts. They're going to have repeatable patterns, so this can be replicated across all your accounts. Permission boundary is another great example wherein you know what is the maximum set of permissions, say you want to allow an application, and that's again, you can commonly replicate it across your accounts. But if you want to create if your team is working on applications, based on what team is building it, based on what the application is achieving, the kind of things that the application does tends to change. So here, instead of creating a template, you can create examples that the developers can use as a starting point and work from there. So identify, talk to your team, talk to your organization to identify what are the use cases that happen across your organization, and start creating the same policy for those use cases across all your accounts. The next strategy is to peer review and validate policies. If you remember, Josh mentioned a while ago that least privilege is a journey, and feedback loop is a very important part of this journey. And for that feedback, you can either do that through human review, or you can automate it to review and validate what's happening. Let's focus on automation first. Again, another great feature here that I want to talk about is Access Analyzer policy validation. Policy validation is something that helps you while you're authoring your policy to set secure and functional policies. Again, the feature is available through APIs and in the console. How you can use it in the console is, if you're using Policy Editor to write any policies, as you're doing that, a small window pane opens up below the Policy Editor that shows any possible issue with your policy. And how Access Analyzer finds it is, it runs more than hundreds of checks on your policy based on what we think is important on our side, and Access Analyzer highlights any possible issues that you might want to fix, and it actually gives you some steps on how you can address it and how you can get rid of that issue. So the example that you see here is, you have pass role action, but resource is star, so Access Analyzer thinks it's going to be overly permissive, so you might want to go back in and add the exact resource information in there. So this is what we would call a security warning. Like, Access Analyzer would flag this issue as a security warning. There are some other buckets in which Access Analyzer or policy validation shows you some more issues. Error is a classic one, which is anything that prevents your policy from functioning as intended. So an example would be misspelling of an action. We saw the example for security warning earlier. General warning is anything that does not conform to AWS best practices. So for example, if there was a condition key that's deprecated, then Access Analyzer would flag that. This doesn't harm your policy, but it stops your policy from functioning the way you intended, and Access Analyzer is calling that out. And finally, the tool also provides some suggestions that, for example, if you have the same resource called out multiple times, Access Analyzer would flag that to help you improve the quality of your policy. So if this is something that you've not tried out, I would really ask you to go check this feature out. One technique that can help us with both peer reviews and automation is use of infrastructure as code. Having your policies version controlled, stored somewhere so that you can test and easily deploy that into multiple accounts. Let's take a look at how we can do this. This is a very simplified version of your CI/CD pipelines. You have commit, you have validation, and you have deploy. In the commit stage, if your developers are authoring policies, then you can quickly incorporate some peer reviews in there. Whenever someone is saving a policy, you can ask for the policy to be peer reviewed, and this is a great way of incorporating that feedback loop. And this creates some accountability in the developers or in your team to write good policies. And if you want to use automation instead, you would use that in the validation stage, wherein you can incorporate the validation tool that I talked about earlier to automate the whole process, and this blog talks about that. The final strategy we have here today is to remove excessive privileges over time. When we talk about removing something, it generally needs to be substantiated by some kind of an analysis. And IAM or AWS offers a lot of data to help you with this analysis. You can start broad at the SEP level to identify, okay, what are the services denied in my SEPs? What are the ones that are not, but are not being used, to identify those and actually deny or restrict access to those services over time, so that at the organization level, you just retain access to the services that are actually required in your accounts. And then you can go a little more narrow at the account level to identify what are all the roles in your account, which are the roles that are active, that are actively being used, what are the inactive ones, to identify those inactive ones and remove those from the account. If you then find that, okay, there are a lot of roles that are still being used, I go a next step deeper to identify what are the permissions granted to this role, what's being used from those permissions, what's not being used, and remove those unused permissions. And finally, if you want to go more granular, we say, look, take a look at CloudTrail, identify the resources that are actually being used by this role, and restrict permissions to just those resources. So I want to double click on step 3 here. Again, this is something that's available through APIs and console. In the console, if you're on the role page, there's something called as the Access Advisor tab. Click on that to identify all the permissions granted to your role, identify from the last access information what permission is being used and what's not being used, and remove the unused permissions. And identifying and removing permissions is a constant thing. You tend to do this routinely. So to save your bandwidth, we recommend automating this process. Either use config rules or use CloudWatch, or it can be some custom script on your side that tells you, hey, these permissions have not been used in the last 90 days, go in and take a look. So this sort of helps you be on top of all of those investigation activities and helps you save time. And one mental model I want to call out here is the 80-20 rule, which says basically that 80% of your outcome comes from 20% of the effort. And whenever we talk to customers, we hear this often, that least privilege is great, but I want to focus on just enough privilege. And this is important, like, for you to figure out what that acceptable spot is. And also realize that anything after that is going to have diminishing returns. And if you still want to work on the remaining 20%, identify what processes work for your organization, like feedback loops, and incorporate those. And also be pragmatic about the remainder of the effort. For example, we say focus on what is sensitive to your accounts and your team. For example, focus on prod role first and then move on to the development roles, development accounts. And if you have roles with external access, focus on those first before going on to the roles that are used in development accounts by your developers. So identify what's the sensitive information in your account, target that first, and then iterate over to the next ones. So these are the key strategies that we have for you today. I'll pass it over to Josh to talk about the key takeaways.
Thank you. So we covered a lot this morning for an 8 a.m. session as well. So just to kind of recap, I'll leave you with one last mental model, that the map is not the territory, right? We keep talking about least privilege as a journey, and I think that a confident journey needs a map. But it's important to realize that maps are not a perfect representation of the territory. They have a similar structure, which can be useful, again, to kind of rationalize about the territory. And this is just an attempt to kind of summarize everything that we talked about today into a cause and effect diagram in order to show, set, verify, and refine with a feedback loop as well, with the individual controls and capabilities layered in there. But remember, you'll want to actually go walk the territory and get your hands dirty to understand how these things work together, and empower your builders and your decentralized teams to do that as well. So we talked about 9 different mental models, but the ones I really want to highlight here are the feedback loops, and that it adds up through continuous improvement to that journey, as well as the 80-20 rule, right? Maddie mentioned that if you put in 20% of the effort, you can get 80% of the results, and then where you want to hyper-focus that last 20%, which does take more effort, and focus on the right kind of sensitive areas or perhaps environments in order to make sure you're using your time more pragmatically or to get the most bang for your buck, so to speak. Right? We also talked about 9 different strategies for least privilege. I don't have a favorite here that I'm going to highlight. I think they're all relevant. They're all important. They kind of all add up on top of each other. Yeah. And lastly, I also want to mention some notable projects. We didn't feel we had time to cover them well or to compare and contrast between them. So I do just want to highlight them here. AWS created some of these. And then customers like Netflix and Salesforce created these as well, just for some custom tooling that might help you in order to craft good IAM policies or to manage your identity and access more effectively. And we're including these just kind of for reference for you to either look up later if you watch the recording as well. And so if you're looking for some key takeaways or next steps, we got you covered. If it wasn't obvious, we're biased towards IAM Access Analyzer. We think it's a great service and does have essentially 3 components to it. So I encourage you to turn it on, use it to find some unintended access to our resources or data that's being externally shared, and go remove that unintended access. You can also use that policy validation function and feed in some pre-existing policies and see if you can improve those. And then lastly, the policy generation capability. If we didn't mention it before, IAM Access Analyzer is free. The policy generation piece, I want to call out that it does use CloudTrail, which if you're turning on CloudTrail, it's storing those logs as objects in S3, so there is a charge for that. But the IAM Access Analyzer service itself is free. All right, and so with that, I just want to thank you again for coming to Reinforce, for getting up early and attending this session. Please complete the survey so we can hear your feedback and improve for next year. Thank you.